Hello everyone, my name is Bilal Berkaçar. I am the Physics102 student at Bilkent University. In this project, I investigated the eddy current, damping, and Lenz's law. When a magnet moves near a conductor, the magnetic flux changes. According to Lenz's law, this change induces circular currents inside the material, called eddy currents. These currents create a magnetic field that opposes the motion of the magnet, producing a drag force. As a result, the magnet falls much more slowly inside a conductive tube than in a normal free fall. When the drag force increases, the magnet reaches a lower terminal velocity. The terminal velocity is given by the first formula. A larger value of B means more damping and a slower fall. We also know that damping force becomes stronger when the air gap between the magnet and tube wall becomes smaller, approximately as the second formula. So even a small change in the diameter can produce a large change in the fall time. The aim of the experiment was to measure how the fall time changes for different tube materials and different sphere diameters. We test copper and aluminum tubes, each approximately 70 centimeters long, and we used spherical magnets with diameters of 1.1 centimeter and 1.2 centimeter. We repeated each measurement 5 times to obtain reliable average values. First, I measured the length and diameter of tubes. The copper tube had a larger inner diameter, while the aluminum tube was slightly narrower. Then I dropped the magnets down the tubes and recorded the fall times. To make the comparisons fair, the aluminum tube was longer, so I released the magnet from approximately same effective height inside the tube. Using another magnet to start from middle of the tube, each thing here shows one of the trails. The results were very clear. Normal free fall took about 0.35 seconds. In the copper tube, the fall times increased to 1.30 seconds and 2.50 seconds for the two sphere sizes. In the aluminum tube, they increased to 2.50 seconds and 5 seconds. This means the motion became 14 times slower than the free fall in the aluminum tube. The reason is geometry. The aluminum tube had a smaller inner diameter, so magnet was closer to wall. A smaller gap produces stronger eddy currents, so damping was much stronger. In conclusion, the experiment confirmed the Lenz's law and showed that both material and geometry affect the damping. A small change in the sphere diameter caused a large change in the fall time, which matches the theoretical prediction. That formula. Thank you for watching.